Hey everyone, we are going to start in about a minute. We are just waiting for everyone to join and then we'll start. Okay, cool. Hi everyone, are you guys able to hear me? Just drop a quick yes or no in the chat. Everyone, just drop a quick yes or no, guys. If I'm audible to everybody. Puneet, have you actually shared this on the group, on the Discord group also? I'm good, Vinayak. How are you guys doing? If not, then can you please share it on the Discord group as well? Yeah, still you have to share it in the Discord group. It doesn't matter. And both of the courses are not going parallelly, so it doesn't matter. Okay. Cool. Okay. So till now we have discussed a basic structure of how exactly Spring works, a few things around the internals of Spring, so on and so forth. And now it's a good time to actually start a discussion on a pretty interesting topic, right? And this is going to be something that is going to be required for you in order to make sure that doesn't matter whether you're going to write code in Spring Boot or you're going to write code in something else. This particular knowledge is going to be required everywhere, more or less. Okay, so we're going to talk about MVC. How many of you guys know about MVC, what MVC is, how can you use MVC, what is the requirement of MVC, so on and so forth? How many of you guys know about MVC and everything? Anybody? Okay, so we're going to discuss a lot of things more or less around that, Abhijit. Model view controller, how flow goes, da-da-da. Okay, those people who are from the backend batch must already know a lot of things already. So no problem. Okay, let's start talking about it. So in order to build any backend application, an important aspect comes for separation of concerns. Okay, an important aspect comes for separation of concern. Why do you need separation of concern? You don't want to be in a situation where inside your application, there is one code file that is handling every single thing of your application, right? Now you might be thinking, why not? Why not just one file and that can handle everything for us? Why not that kind of a scenario? Let's think about it. Let's say as of now, you are building some kind of an e-commerce application. Okay. In this e-commerce application, as of now, you were using MySQL database. Okay. And here, let's say there is some particular file where you are writing your business logic. Business logic means actual core logic with which most of the things around your application is working. Now, think about it like this. If you have a very tightly coupled code, then what will happen? Your code will become unmanageable. Why unmanageable? Just think about it. Let's say in the same file, you are writing your business logic also. And in order to achieve this business logic in the same file only, you are doing DB interaction also. DB interaction means you are executing your database queries and everything also, just like directly here only. Now, let's say later, maybe MySQL is not enough for you and you want to migrate to maybe something like PGSQL, some other database you have to migrate to. Then what will be the biggest issue here? The biggest issue will be that you have to go to your business logic, because your business logic and your database, all of these interactions are very tightly coupled, that you have to go to your files where your business logic is written and make changes in those files. Despite the fact that there is no change going to happen in your business logic. Okay. There is no change going to happen in your business logic. It's just the database that has changed. So probably the database queries might change, but your business logic still remains same. You were e-commerce 5 hours back also. You are e-commerce now as well, right? The only thing that has changed is your DB interaction. Just think about it. For your DB interaction, don't you think it will be too hard for you to actually go through all of your business logic code base and rectify all of the queries with the new PGSQL based queries? Plus, testing of this kind of a code is going to be very difficult. Why? Because you are going to make changes, or you are going to touch base on a lot of code structures, and there can be a case that there are some bugs introduced in your whole code, right? So testing of this kind of a very tightly coupled code is going to be, I would say, pretty time taking. Okay. That's where our concept of separation of concerns comes into the picture. Separation of concerns says that whatever module of your code you are writing, that module of code should be having its own separate logic. It should be having its own separate role to play, and it should not hamper or it should not get hampered due to any change in some other piece of code. I hope this point is making sense to everyone. How many of you guys are able to get this point? What I'm trying to say here? How many of you guys are able to get this point? What I'm trying to say here, guys? Everyone in the chat. Do you guys understand what is the concern that we are having here? Somnath, what about you? Do you understand the concern what I'm talking about here? And this is not just related to Spring Boot. It's related to any piece of code that you are writing. Okay. Make sense? So any framework that you are using Ruby on Rails, you're using Spring Boot, you're using Express.js, .NET, any framework you are using for anything, like even if you're building a backend application, you are building an Android application, you are building a front-end application, whatever you are actually going to do, this logic of separation of concern should always exist. that you should not have a very tightly coupled code, else it will be very less manageable. It will be error prone, and changes to this kind of a code or maintenance of this kind of a code is going to be very time consuming. That's not going to be overall scalable altogether, right? That's why we have a bunch of patterns for different applications. For example, for building Android application, there are a bunch of patterns. For writing backend application, there is a pattern, so on and so forth. And these patterns actually help us to implement this kind of a single responsibility and separation of concern kind of a principle. One of such famous patterns is MVC. Okay, it's a pretty, I would say, famous architectural pattern altogether, using which you can structure your code very well. Is it dependency inversion principle? No. Dependency inversion principle is just with respect to classes and everything. No. Think about, you don't have any classes or anything, like you have a functional language altogether. Then also separation of concern needs to happen. Are you able to get this point, Ayush? It's kind of like a design pattern only. Design pattern is anything that helps you to structure your code well. Design pattern is not just builder pattern, and design pattern is not just factory pattern, everything. Any, I would say, coding advice or anything that helps you to structure your code better is a design pattern. Okay. So now, in order to understand MVC, there is a very simple example that you can take. And I always take this example in most of my classes. Let's say you go to a restaurant. Okay. Let's say you go to a restaurant, right? When you go to a restaurant, it's not like, and let's say you are going for a fine dining restaurant, right? You go to the table. It's not like you directly go into the kitchen and start ordering the chef that, hey, please make this thing for me, please make that thing for me, so on and so forth. That's not how it works. What you do is you sit on your table and, like, let's say you are here, the user, you sit on your table and you start reading a menu. You start reading a menu. Menu contains everything that you can actually order in your restaurant. It is kind of like the first interaction that you as a user are going to do. Now, once you read the menu, then what happens is probably a waiter will come to you asking that, hello, sir, hello, ma'am, what do you want to order today? Then by looking into the menu, what you're going to do is you're going to tell them, okay, these are the 2-3 dishes that we want to order. And then what this waiter actually does is it notes down your order, takes your order to the kitchen. Okay, takes your order to the kitchen. Inside the kitchen, there is your chef. The chef receives the order, prepares the food accordingly, and then keeps the food ready for this waiter to pick. And then the waiter comes up, picks this prepared food and deliver it back to the corresponding user. That's how a normal restaurant generally works. Can I say that? Yes or no, guys? That's how the normal, pretty much a normal restaurant works. Yes or no? Okay, cool. Now, interestingly, what happens is that a similar kind of a code structure you can prepare for your applications as well. If you carefully see, then the role of this waiter is not to prepare food. Waiter doesn't prepare food. The role of the waiter is very simple. Just collect your order, get the order to the kitchen where the chefs will prepare your order, and then take the order from the kitchen, take the prepared food from the kitchen and deliver it back to the user. That's the only responsibility of this waiter, right? Same thing for kitchen and this chef. The whole logic, the whole core business logic of the restaurant, that let's say it's an Italian restaurant. So how they actually put so much, like how they prepare so tasty food, how exactly they prepare so much food so fast, what are the ingredients they are using. All of this logic is your what? Business logic. Your waiter doesn't need to be concerned about your business logic. Like waiter doesn't need to be concerned about the fact that how the food is being prepared, right? Waiter has no concern about it. The whole logic of the food being prepared resides inside the kitchen, right? And the user is not aware about any of this. User just gives the order to the waiter, and then waiter takes the order to the kitchen, where all of the logic, all of the magic actually happens. Chef prepares the food, and then waiter takes the food and delivers it back to the user. You can see in a very simple fashion, restaurants are able to actually maintain separation of concerns. That waiter doesn't know what's happening in the kitchen. Kitchen doesn't know how waiter is handling all of these orders. User doesn't know how exactly any of this is working. User is just interacting with the corresponding waiter. That's it, right? That's the whole structure of a restaurant. Now, in a similar way, you can understand MVC as well. So what is MVC? MVC stands for models, views, and controllers. Okay. Now, what is models, views, and controllers? Can I say that this menu is kind of like the interaction part where user is able to see what are the options they can actually have in the restaurant, what they can order, what is the price of something. That's kind of like the visual representation that the user can expect before an action, before doing any action. Can I say that? So this menu here is acting kind of like a view where the user is able to see and interact and like see that what they can order, what are the options available, what are some of the features, how much, let's say, taxes and everything will be coming up in the bill. Everything is going to be written in the menu. What are their specialities, right? How much amount of things you can order. All of these things are actually available in the menu. So that's kind of like your view. So when you use an application, let's say you want to use something like Zomato. When you open Zomato, then the Android application or the iOS application or the web application that you see, that's the layer which you see, where you are able to see all of the options that you can actually use, what are the available restaurants, what are the food items that you can order, so on and so forth. So that's your view part. That's your view layer. So view technically resides or technically refers to the front end of the application. This is the layer where the user can actually interact. In the layer of views, you write all of the logic of user interaction and user display, that how to display everything very neatly, very nicely, how to write the CSS for all of your web applications so that it looks nice. User are able to interact with this. You are able to track user interaction. All of that goes in the front end part. That's your view layer. So view layer is responsible to maintain everything which the user sees. Now, this waiter acts as your controllers. So what is controllers? Controllers are those part of your code. Controllers is that part of code which is responsible for collecting incoming user request. It is responsible for collecting incoming user request and provide it to the models and provide it to the models layer. Okay. Then whatever response models give, controllers take that and send it to the user. So you can see the role of controller is very much similar to that of a waiter. Controllers are responsible to collect the request from the user. They do not process the request. You can see here also, waiter doesn't cook the food. Waiter doesn't process the user request. Similarly, controller also doesn't process user request. They just collect the user request and pass it to the models. Okay. And then whatever response models give you, they take that response and send it back to the user. Now, the question that should come to your head is, what is models in that case? Models is actually your kitchen. This is your models. Models is the layer of your code or a part of your code where all of the business logic resides. So what is models? This is part of your code where all the logic resides. I hope this point is making sense, right? So all of the logic, or you should say business logic, right? All of the business logic. Business logic means that how to actually handle the catalog of the, I would say, pages, like different product catalog, how you want to handle, how will you accept payments, how will you manage the cart, how will you manage discount? All of this is what? Business logic. Now, controller layer is independent of the models layer. Controller layer has nothing to do with the models layer. Controller layer is expected to be very thin. Very thin means there is not much of a code that you write in the controller layer. All controller layer is expected to do is it takes the user request and pass it on to the models. That's the only thing that controllers actually do, right? And all of your business logic actually resides inside the model. So technically, models is kind of like your kitchen where all of the magic happens, all of the actual cooking of the food happens, where the chef prepares all of that food and then sends it back to the corresponding waiter. And then the waiter picks up, or you can say controller picks up the response and send it back to the user. That's how exactly MVC work. Now, wherever I'm saying layer of code, you can say assume that whenever I say layer or part of your code, I'm referring to some kind of a package or some kind of a class or some kind of a function, right? Some module of your code, some part of your code is going to be responsible for collecting the request. Some part of your code is going to be responsible for processing the business logic. And then the same part of your code that collected your request will be responsible for sending the response back. That's how exactly MVC pattern works. How many of you guys are able to get this point? Drop a quick yes or no in the chat. Are you guys able to get the association between the two stories? It's pretty simple. Ashish, I'll come to that. Don't worry. Okay. So Anjali, monolith and microservices has nothing to do with MVC. In monolith also you can have MVC. In microservices also you can have MVC. MVC is responsible for structuring any piece of code. That can be a monolith, that can be multiple microservices. So each microservice might be handling MVC. No problem there. Okay. Yes, Rachel, you can say that. Okay. Yes. Somnath, kitchen is the model here. You can say Spring MVC helps you to implement the MVC pattern well. MVC concept exists independent of Spring. For example, let's say in this whole world, Spring Boot never existed or Spring framework never existed, still MVC exists. Ruby on Rails follow MVC, Django follows MVC. So MVC is a overall coding pattern. It is independent of any framework. Vimal, so let's say now you can think about it, right? If we have to write our backend logic, for writing backend applications, we will use this MVC architecture. Okay. Vimal, guys, I want more questions. I believe the whole topic expects a lot of questions. Few I will park because I'm going to eventually answer it, but I want more questions from everybody. Okay. So to structure different code, I would say projects, there are different patterns. For example, if you go to Android, if you have ever done, and not only Android, any kind of a mobile development altogether, then in mobile development also there is a MVC pattern for Android. You can search for it, MVC pattern for Android or iOS, whatever mobile application you're building. Okay, you can see there is a model view controller for Android application also. It has some sense very similar to that, but some different sense also. There is a MVVM pattern also. There are more design patterns when you do mobile application development and everything. Okay, you can see alternative of MVC for backend application, right? So you can see there are other patterns as well. For example, there's something like Flux, right? Sorry, not, I guess this is different. One second. Alternative to MVC. You can see there is MVP, model view presenter, right? Different architectures actually exist. Okay, there are other, you can see there are other architectural patterns. There is layer-based pattern, multi-tier pattern, model view presenter pattern, pipeline pattern. A lot of patterns are there, right? But MVC is kind of like one of the most famous ones, which is widely accepted. And a lot of frameworks like Ruby on Rails, Spring, Django directly implement a lot of things around MVC. For example, let me show you an example. If you make a brand new Ruby on Rails project, okay, if you make a brand new Ruby on Rails project, then what happens is, if I show you Rails project structure, or I can show you on my GitHub also. If you make a brand new Ruby on Rails project, then let me sort it by what Ruby. Ruby option in it. Okay. For example, if you actually make a brand new Ruby on Rails application, these are all of the folders that will come up. If you go to app, then you can see there is a controllers folder, there is a views folder, and there is a models folder. Can I say that? Okay. Anjali, अभी हम लोग और bifurcate करने वाले हैं. So just wait for like 5 minutes. We'll discuss that. Sir, as Vue is front-end part, then we need Angular React for the front-end part as for bigger project. Yes. So now most of the modern projects, your Vue part is like earlier when React, Angular and everything was not there. You used to do server-side rendering only, right? So in that case, Vue's part was also handled in the backend logic only, because then you get the data from the database and everything and populate the HTML and then send the HTML altogether. But now generally this Vue part is now handled separately in a different React, Angular or Vue project or something like that. Yes, the MNC, Akash, the MNC will be used in the backend. We exist on the front end separately altogether. Okay, so we don't have to worry about views, right? Views are going to be front end. That's going to be absolutely different. Okay. You might be thinking that how exactly views now comes into the picture, views how interact. So now generally we only write API driven code. We only write API driven code. So what views will happen is, so now you do not need to handle views in your backend logic. Views are going to be a separate React or Angular project, and they are going to interact with our backend logic through APIs. That is going to be something that we will do. Okay. But now this whole MVC architecture that we discuss is it's a very superficial and a very high level architecture where a lot of things we have not discussed. For example, when I say kitchen, in a kitchen also a lot of things happen. In order for chef to prepare the food, you have to get the raw materials, right? Does chef gets the raw material themselves? No. Somebody else is there who maybe handles the operations, who gets the raw material for the chef. Can I say that? Sometimes user can ask the waiter to prepare something apart from the menu, which is not written in the menu. And the user might ask the waiter to bring a food which was not the part of the menu. And then how the waiter will actually handle these kind of scenarios, right? So there are a lot of things. There are a lot of things that we have not discussed about all of this whole restaurant architecture. And same thing exists here as well. When you say that models is going to handle your business logic, it's a very abstract term to say. Why? Because in order to handle the business logic, most of the time in our business logic, there are 2-3 things. First is your algorithm, the actual logic. Second, the entities involved in the algorithm. Like for example, you want to do booking for a user or place an order for a user. So order is an entity, products is an entity, user is an entity, which are going to be involved in the algorithm of booking an order. And then there is data interaction. And then there is data interaction altogether. What happens in the data interaction? Now, in order to get what is the details of the user, which product you want to actually place the order for, what is the quantity of the product, what was the price of the product, and based on the quantity, you calculate the total price of the order. All of that requires data interaction as well, or DB interaction as well. You can see all of these 3 things are clubbed together to make the business logic, right? Same thing here. Here also you have a chef who actually does the actual algorithmic part or the actual cooking part. But there must be a operations person who will be going to the market and bringing the raw material. That's the data for your corresponding chef. And then inside the kitchen, there are a lot of, I would say, pre-prepared food, right? A lot of things actually go on inside the restaurant. So same thing for our backend application also. It might be just very abstract to say all of your business logic goes to the model. Because the moment you do that, again, there is a very tight coupling between the algorithmic part of your business model and the data interaction part of your business model. Are you able to get this point? Same thing for the waiter as well. Now, how will the waiter handle a situation where user is going to give an order which was not present in the menu? Same thing can come for our controllers. Controllers are going to accept the API request, send it to the models, and then give the response back. But what if a request actually comes up which the controller was not aware of, or the request that came up to the controller was not correct based on the API contract? How the controller will handle it? So in that case, the logic of handling validations plus collection of the request and giving the response, both of them goes to the controller. So just saying that is also not going to be pretty much right? So this MVC architecture on an Uber level looks very good. But actually, if you go to the industry and if you actually start writing code, there are more set of things that actually happens behind the scenes. And that's what we are going to actually talk about. So what you can actually do is you can divide your whole application into a bunch of layers. Okay. So I'll write it like this. First of all, let's say this is your view. Okay. Let's say this is your view. From your view, when the request comes up, the first piece of code that is going to collect the request again is going to be what? Controller. This is going to be controller. Now, just saying that controller is going to collect the request is not enough, because how the validation will happen? So what will happen is controller is going to also interact. Controller is going to also interact with a validation layer. So there is going to be a different layer of your code. There might be a different package that we can keep for all the validations. So where all the actual validations will happen inside your code. So whenever the controller is going to accept the request is going to first pass through the validators. If the request has been validated, then it's okay. Then the controller will accept that request. And then the controller has to send that request further. Now, earlier we were just sending the request to the models, right? Now we are not going to just send the request to the models. The whole models layer is now going to be divided into multiple parts. This algorithmic part is going to be called as services. This data interaction part is going to be called as repositories. Okay. And these entities part in itself can be called as schema, or sometimes people call this also sometimes as models only. So you can say that this Uber level model, this MVC model, will now be divided into multiple layers: services, repositories, and schemas. Okay, so let's talk about it. So what controller is going to do is, controller is going to pass the request to something called as services. The controller is going to pass the request to something called as services. Services are going to be responsible for containing the algorithmic part of your business logic, your actual business logic. But in order to implement this business logic, services are going to be dependent on two things. One is your entity. Now, what is an entity? You can say entity, or you can say schema, or you can say models, anything, right? Let me write it properly. So let's make it a slightly bigger one. So services are going to be responsible for interacting with your entities, which you can call as schema, or you can call it as models as well. Okay. Now you might be thinking, what is this entities? Now just think about it. You want to store the data of product in your database. Database you want to choose is MongoDB, MySQL, whatever you want to choose. But what was the real life entity for which the data you wanted to store? Product, right? Now we write code in Java, TypeScript, JavaScript, Ruby, Java, all of these languages, where we actually understand real world entities through what? Classes. So let's say you have a product table. Now my Java code knows nothing about tables, right? My Java code knows only about classes and objects. My Ruby code only knows about classes and objects. Ruby has nothing to do with tables, right? Ruby has nothing to do with documents, right? So what will happen is, in order to implement this business logic, you can't say that I have a table. You have to represent those tables in the form of classes. Those classes we are going to write here in the form of entities. Okay, in the form of entities. So this entities is going to be responsible for the representation of the database in your actual backend logic, right? Now, in order to represent these entities, you can write a lot of things. For example, you can write your normal classes, right? Sometimes, let's say, if you're using something instead of REST, if you use something like gRPC, you can represent these entities using protocol buffers. And these protocol buffers will automatically create classes for you, right? So these entities can be represented through anything. But these entities are going to be very much required in order to implement our services, because they are going to be the logical view, the class view of the actual data inside. That's what is the representation of entities. And services will contain the actual algorithmic part. For example, you want to write the business logic for creating an order. Now, in order to create an order, what do you need? You need a user, you need a product, right? And you need to create an order. Okay. Now, why do you need user? Because this order is going to be associated with this user. Why do you need product? Because using the product only, based on the quantity of the product, we will be able to calculate the total price. Okay. So there will be a user class, there will be a product class, there will be an order class. All of these classes are going to be your kind of like entities, right? And what will be your service part or the algorithmic part? The service part or the algorithmic part will be to actually get the price of the product, get the quantity of the product, multiply both of them, and do the summation of this for each and every product. This summation is going to give you the total price, right? You can say this is one of the algorithms that you can keep, that you have a list of products, you have their quantity, and you have the individual price of one product. You multiply every product with the price of the product with the quantity, and then sum it up. That's your algorithmic part. That's your logical part. But the representation of this data is going to be formed in the form of a product object, which will be actually defined in a product class. That's your entity altogether, right? That is the difference between this entity or schema or model when compared to service. So the service layer only is responsible for the logical part. Okay. Now, think about one thing. In the entities, you represented the classes, which is the logical, or you can say the object-oriented view of your database. Here you wrote all of your business logic. Don't you think there is something missing? That is data interaction. This product class is not going to automatically go to the database, make a query, select star from products, and bring the products back, right? You need to have a layer that is going to be responsible for executing your queries, for actually communicating to the database, right? Think about it. You do not want to put the logic of communication with the database in the service layer, because what will happen? If let's say you want to change the database, currently you were having MySQL, you tightly coupled the SQL query logic, the logic where you are executing your SQL queries also in the database in the service layer only. Now, what will happen if you have to change the database? You have to make changes to the service layer. And this will cause bug in your system, because all of the business algorithmic logic was actually present in the service layer. Testing will become hard. So for that reason only, services are going to be dependent on one more layer. Services are going to be dependent on one more layer called as repository layer. Repository layer. Right. What is repository layer? In the repository layer or the repository package, we are going to keep all of those classes which are going to be responsible for data interaction. Okay. Responsible for data interaction. Okay. This is going to be responsible for actually executing a query inside your database altogether. Right. Your service layer is not going to execute queries for you. Your service layer will need these queries. Now, for example, just think about it. Your service layer now has to do one thing. Your business logic, this whole business logic has to do one thing. It has to calculate the total price of your cart. Now, in order to get the total price of the cart, you need to get the data of the product. Now, who will get the data of the product? This repository will connect to the database, collect the data of all of the products that are present in the cart, maybe based on the product ID, and give it to the service layer. Now, service layer is now going to execute this logic where it will multiply the price of the product with the quantity and calculate the total price. Right? And to implement this logic, because this doesn't know about anything about what? Anything about your tables. It will be dependent on the classes that this entity layer is going to give you. So you can see they are going to be depending on each other, but they are not going to be very tightly coupled with each other. Because for example, currently, let's say inside our repository, all the MySQL queries are running, right? But my repository is going to just give you a function, get product. My repository is going to give you a function get product. You will, from services, you will call get product. Now inside get product, whether you are executing MySQL query, whether you are executing MongoDB query, whether you are executing PGSQL query, it doesn't matter to services. Services will call this get product function, and get product function will do the required query execution. Now let's say currently you are on MySQL, you want to migrate to PGSQL. You don't need to touch your service layer, because service layer though still will actually call the get products function. All you have to do is just come to a repository and update the repository. So inside the repository, there will be multiple functions. One of the function will be get products. So you will update the query to get the products accordingly. But the service layer is going to be independent of it. The service layer doesn't need to bang their head anywhere in order to identify this particular fact. This is why you need detailed separation of concern inside your code. How many of you guys are able to get this point? So data from DB will be fed to entity, right? Then why repo is next to service? It should be next to entity. No, it's not next to service. Can you see? I have made service interact with both of them. It will be a close interaction. Are you able to get this point? One more thing I can tell you. Now, there can be one more reason to use a separate repository than services. For example, let's say there is a premium user. Let's say there is a premium user. Okay. And there is a free user. And there is a free user. For premium user, you want to make sure that your queries are not executing with the highest priority. Sorry, for free user, you want to make sure that your queries are not executing with the highest priority, right? Maybe you want to make sure that the free user queries will take up some time, but the premium user queries should not take up time, right? Or maybe some other logic is also there. Maybe you are caching the logic for caching a lot of things for premium user, but you're not caching a lot of things for free user. You're doing different strategies altogether. Now just think about it. When the request will come, sometimes the request will come for a premium user. Sometimes the request will come for a free user. All of that logic you then have to bind for your services. Instead, you can have a different repository that can manage the interaction for premium users and different repository that can manage the interaction of your free users. As simple as that. One more thing. For example, let's say currently you are fetching the products for your services, right? Currently, you're fetching the product from a database. Maybe due to some reason, now you don't want to fetch the data from your database. You now want to fetch the data from a third-party API. Let's say you are building a new feature in your e-commerce application, right? Where let's say you are interacting with some other e-commerce application or some other vendor apart from your own product database to actually get the products. In that case, will you embed that logic in the services? No, you are not going to embed that logic in the services. You are going to embed that logic outside of services so that your actual business logic remains clean, remains intact. Make sense, everyone? Yes, Ramya. For example, like you can say that repositories will also be interacting with entities. Repositories will also be interacting with entities because they will also need all of these classes to actually use the underlying ORM and everything. Yes, you can, Somnath. No, Ramya, caching part is not your code structure part, right? That's your high level design part. I'm just saying, maybe there's a caching strategy also coming into the picture. Here we are MVC about how you structure your code. It's not about how you structure your app or how you design your app. It's not about that. It's about how you structure the code of any particular service. Make sense? Yes, Somnath. Very good. Now, there are a few things. Now, of course, a backend application is not as simple as that of a restaurant. There are more things as well. For example, let's say whenever you place this order, you want to send an email to the user also. But that email SMTP server you don't own. You are relying on some third-party service like, let's say, Twilio to send the emails. Now, your business logic of placing the order is present inside services. To place an order, the services will be depending on repositories to get the product. Then it will calculate the total price of the order. Then it will be again depending on repositories to place the order. But now where the logic of third-party APIs will go, because now this service needs to either handle the emailing logic itself, or it has to maybe call Twilio API. Twilio API we don't own. For example, we are Flipkart. Flipkart doesn't own Twilio API. All you have to do is you have to make a call to the Twilio API. In that case, you are going to have an API layer as well. You are going to have an API layer as well, where your service layer will be interacting with the APIs. Now just think about it. Why do you need it as a separate layer? We need it as a separate layer because let's say currently we are using Twilio, but Twilio has started charging us too much. Now we want to shift to some other mailing service. Let's say SendGrid. I guess SendGrid is owned by Twilio. I'm not sure, but I'm just giving you an example. Let's say we are shifting to something else, maybe MailChimp. Okay. Now the API logic, the request structure, response structure of MailChimp is going to be different than Twilio. If you want to change your emailing service, why do you want to make changes to your service layer? The service layer will be just calling a function send mail. This send mail function will be written inside your API layer. Now this API layer will be responsible to make sure that it automatically understands what's the incoming request and then modify the request to send it to MailChimp if you are having MailChimp, or to send it to SendGrid or Twilio, whatever service you have. So you can have a different API layer coming into the picture to interact with third-party services as well. Are you guys able to get this point? I'm coming to that point. Anjali, I know you're referring to a very specific thing, so I'm coming to that point. Make sense, everybody, what I'm talking about here? No, Puneet, मैं बता रहा हूँ क्या होता है वो. Sir, for sending mail, we use API. We will not write logic inside service every time. नहीं, क्योंकि मेल सेंड करने के लिए तुम्हें अपना SMTP सर्वर सेटअप करना पड़ेगा, राइट सोमनाथ? तुम ई कॉमर्स ऐप हो, तुम्हारा काम है सामान बेचना, कपड़े बेचना. तुम SMTP सर्वर को स्क्रैच से सेटअप करने का हेडेक क्यों लोगे? Of course, if you are at a scale of Amazon or Flipkart, then of course you can. But अगर तुम let's say brand new startup हो, you don't want to go into the hassle of setting up your own SMTP server. फिर उस SMTP सर्वर को मेंटेन करने के लिए 4 डेवलपर चाहिए. Yes, in fact, payment gateway also. In your API layer, payment gateway can also go. Right? मान लो अभी तुम्हें currently your payment gateway is CC Avenue. Now let's say CC Avenue has started charging you too much and you want to migrate to Razorpay. Why do you want to change your service layer? All of that interaction will go inside your API layer. Are you able to get this point? Now, an interesting part that exists with this API layer is that now this API layer where your third-party interactions will go, this is going to be having some contract as well. Like whenever you are going to make an API call to any third-party service, that third-party service will be expecting something from you. For example, it's a payment gateway API. So that maybe payment gateway is expecting the user ID from you, then payment mode from you, and then let's say credit card details from you and a few things. So this is going to be a contract in itself. Can I say that? Right. Now for this particular contract also, there will be some classes that you have to maintain, right? Because in order to make this API call, you have to create that object and then make the API call altogether, because that's the contract that you are going to send, right? And if you're using a type safe language like TypeScript or Java or let's say C#, then you need to make those classes altogether, right? If you don't know what is the meaning of contract, when I refer contract, I'm referring to API contract. API contract means now Razorpay will tell you that what is the URL that you need to hit. What is the HTTP method, get, post, put, patch, what do you need to hit? What's the request body that you need to hit it with? Are there any query params that you need to hit it with? And so on. So altogether, this will give you a contract that Razorpay or the payment gateway will tell you that, hey, e-commerce app, if you want to make sure that a payment goes through me, these are the input items that I expect in a JSON format on this particular URL with this particular HTTP method. Send it to me. Now, when you have to send that all of the data in the JSON, let's say Java doesn't understand JSON, right? For Java, everything is what? POJOs or your plain classes, right? So now you have to interact with these classes as well. You have to prepare these classes as well. But these classes has no part to play in your business logic. These classes has no part to play in your business logic. You need these classes to actually interact with some third-party APIs. That's where another layer comes into the picture. That's where another layer comes into the picture that you call as DTO. What does DTO stands for? Data transfer object. Okay. In a data transfer object, you always try to maintain those classes which are part of some kind of an API contract. And the name references data transfer object. It's an object that is going to be used for some kind of a data transfer or data interaction through a network call. Are you able to get this point? Right. So, and in fact, DTOs are not going to be only used for your third-party API interaction. Even for your controllers, when your controller is expecting something, let's say your controller is expecting an API to send a request body. Now that request body you are going to accept as a class, right? As a class object. Spring will automatically convert that for you. But you have to define that class somewhere. So you will see DTOs being used inside the controllers as well. Because again, what is the use case of DTO? To define some API contract. Now your own APIs will be having some contract. Your own APIs will be having some contract that maybe some front-end layer will hit. So you have to define that contract inside your layer as well. And you have to define the contracts that you want to hit as well. Right? So you will see DTOs containing a set of classes that are responsible for defining some kind of a API contract. You can read more about it as well. So if you read about DTO, you can see data transfer object, which is an object that carries data between processes in OOPS, in environments like Python, C++, Java. DTOs are used to change the shape of data that is sent to a client, right? You can see. So whenever there is going to be interaction between processes, right? That interaction you can actually do by defining the DTO classes, because of course, eventually you are going to create an object, serialize that object, send that, right? But in order to create an object, you need a class, right? That's where your DTO classes actually comes into the picture, right? This is something that you have to always keep in mind. Now, apart from DTOs, there is one more concept called as DAO, DAO, DAO. So generally, in most of like those people who follow the conventions properly, the repository layer sometimes is also referred as the DAO layer. What is DAO? DAO stands for, or DAS stands for data access object. Now the name mentions it, data access. It is an object that is only responsible for fetching the data for you or interacting with the data for you. Data access, some kind of an access or interaction to the data it is going to do. So the DAO layer is same as your repository layer. Here also you will be having some set of classes or some set of functions which are going to actually interact with your corresponding databases. That's what your DAO layer is. So DAO layer and repository layer has not much of a difference. That's why generally you will find people using anything, repository, DAO, whatever you want. Okay. And for DTOs are data transfer object that is going to be used for any kind of a API contract object creation, right? This is something that you have to keep in mind. Also, just FYI, sometimes these entities, right? Sometimes these entities and repositories, right, are clubbed together. Maybe this is one folder, this is one folder, and both of them has a parent folder. And sometimes people call it as a persistence layer. Persistence, because both of them are somehow involved with your database interaction and database representation. So sometimes people club them in one folder and call that folder as persistence layer. So persistence layer folder will be having two folders, repositories and entities, right? So I saw that this in a bunch of code bases. For example, if you go to Zepto, in Zepto, they have a folder like persistence layer that they have defined where a lot of DB interaction and everything comes up. And there are a few more startups that I've seen using this as well. So if this name comes up persistence, don't get confused. And you can see that's the actual MVC we use. So here, if you carefully see, this part is your controllers and this whole part is your models, right? So just saying models, views, and controller is very abstract. In real world, you can have very complex use cases where you have to segregate your logic into different pieces altogether. Time for questions, guys. Abhijit, Pojo is just a Java class. Pojo is plain old Java object. It's a class that can create an object. Pojo has nothing to do with MVC. Like MVC, DTO, DAO will exist in TypeScript, but in TypeScript you don't have a term named Pojo, right? Are you able to get my point, Abhijit? You can say DTO will be the class that is going to actually create the Pojo object, Pawan Patil. You can, so Vinayak, guys, sometimes people can change the namings altogether. Okay. So for example, if there is some kind of a SSR, like because I've worked with a lot of code bases and code architecture. So I've also heard about a lot of time. For example, if there is any API, sometimes these API calls are also referred as remote, because this is not going to be happening on your server. It's going to be happening on some other remote server. People start calling this as remote. Maybe they can call something else as remote as well. Sometimes instead of persistence, they call it as a data layer or a domain layer, right? They call this layer as a presentation layer because this is going to be responsible for showing the, like sending the data to your view, which is going to be used for presentation. Sometimes there's a, like for very complex use case, for example, in Google, we used to have something called as a presentation service altogether, which the front end used to interact with, right? So again, the more complex the use cases become, there can be a few more additions that you will see, or maybe a few naming convention change that you will see. Are you able to get this point? ORM we have already, did we talk about ORM? No, we have not talked about ORM. No, ORM is different. You can say ORM will be used inside here. You can say we will be, in order to implement our repository, we will be using ORM. Okay, Ayush? So ORM theory will come into the picture. मैं बता देता हूँ, अगर तुम्हें अभी जानना है तो मैं 5 मिनट बता देता हूँ, but let me see a few more questions. But they mentioned this thing in design docs, right? Who? When you refer they, then who? Entities for saving to database, while DTO is not related to DB. Am I correct? Yes. DTO is going to be responsible for API design. For example, let's say you want to make an API call to this. Let's say there's a fake store API. Okay. Let's say you want to make an API call here. Okay. And let's go to fakestorepay.com. Okay. Let's say there should be an API to update, add new product. If you want to add a new product, you can see you have to make a post request. And this is the JSON that you have to send. Are you able to see this? Now you need a class that creates this JSON, right? Everybody, you need a class that create an object out of this JSON, because in Java, you don't have a JSON, you have objects. You'll be sending that object and it will get serialized in the form of a JSON. So in order to create that object, you need a class. So we will be creating a product DTO all together here. Guys, Pojo has nothing to do with MVC. Pojo is a Java term that people have prepared, plain old Java object. MVC pattern can exist in a TypeScript code base. It can exist in a C# code base. Now here you don't have a Pojo, right? Because you can't say a C# class or a C# object as a plain old Java object. Can I say that, Chetan? Is that point making sense? Okay. Now what is DTO? When you have an API contract to hit, in this API contract also you will be sending some data, right? In this API contract also you'll be sending some data. To send this data, you need an object. To have an object, you need a class. Yes or no, Chetan? Yes or no, Chetan? For example, okay, you guys are already prepared for this kind of stuff. For example, do you remember I asked you guys to do a very simple task? Remember retrofit task, the task of retrofit that I gave you? Remember, guys? One second, let me close this project. Close project. Okay, so I guess this one. This one was the retrofit one, right? Top. Just a second, guys. Hello, controller. And no, not this one. Where is it? Build system basics. Build system basics. Yeah, build system basics. Here you can see. So if you go here in the main class, can you see retrofit was being used to make this API call? Can I say that? Chetan? Retrofit was the library we were using. Yes or no? Okay. Now, for this, to make a call using this library, you can see we can do get to do by ID, right? We can make a post request also. Now, sometimes you might have to send a JSON object, JSON as well. Currently, though, we just did get to do by ID. Maybe now instead of get to do, we have to make a product altogether. In that case, you have to send an object, right? Can I say that? Yes or no, Chetan? So for that object, you will create a class, right? You will create a class. And technically, when we were hitting, when we were hitting this particular method, we created this Pojo to do. Remember this Pojo to do? This Pojo to do is kind of like acting like a DTO only. Can I say that? Okay. This means both entity slash model class and DTO are doing the same job or less, more or less, only that they interact with different things. Yes, like, okay. So Ramesh is saying the entity or models, whatever you say, and DTO are doing the same job. They are bound to do the same job because both of them are classes. This is also going to be a class. This is also going to be a class. Classes do the same thing. They define blueprint. Now the blueprint that they define for can be different. This is going to define blueprint for your DB or your data models. This is going to define the blueprint for your API interactions. Are you able to get this point? Ashish, retrofit required JSON converter. Spring has its own mechanism also to make API calls. I'll show you that also. So, and JSON converter concept is independent of MVC. Guys, whatever we are discussing here is independent of Java, is independent of Express.js and Node. It's independent of Rails. It's independent of Django, anything. It's a programming concept. It's not related to any framework. It's not a Spring concept. Keep that thing in mind. We don't define two classes for the same thing. Why will you be having two classes for the same thing, Puneet? Now, let me come to this point. Let's say you have a product table where you are storing the product data. Okay. Just listen to me very carefully, guys. Let's say this is your product table inside an RDBMS, maybe MySQL. It has a bunch of columns. It has an ID column. It has a title column. It has a price column. It has created at, and it has updated at. Let's say these are the 5 columns that you have. Make sense, everybody? This is the product table that you have. Okay. Now, when you have to interact with this product table, if I ask you to define a class, what should be the properties of your product entity class? What should be the properties inside the product entity class? There should be an ID. There should be a title. There should be a price. There should be a created at. There should be a updated at. Can I say that? All the attributes make sense? Okay. This looks good. So now whenever our service logic has to get some data from my database, we will need object of this particular class. Now let me give you a situation. In order to populate this database, I'm going to rely on a third-party API. Listen to me very carefully, guys. In order to populate this database, I'm going to rely on a third-party API like Fixstore. Because you can see I can get all the products and get products here, right? So if I make a call to this, sorry, you can see I'll be able to get all the products. So in order to populate my DB, what I'm going to do is from my service layer, I'm going to make a call to the API layer, and this API layer is going to make a call to Fixstore API. Okay. Now, in order to make the call from API layer to Fixstore API, you need a class. Now, do you think this particular class and this particular class can be same? I don't think so. Why? Because Fake store API is not going to give you created at and updated at. See, it's not going to give you created at and updated at. Can I say that? Because created at and updated at is the timestamp of your database. Why fake store will give you? Then fake store is giving you extra properties also that maybe you do not need, right? But to get the data from fake store, when you receive the data from fake store, you need a DTO, right? So what kind of a DTO will define? In the fake store product DTO, you'll be having a lot of properties. You'll be having an ID, you'll be having a title, you'll be having a rating, you'll be having a description, you'll be having an image and whatnot. Now, what your service layer is going to do is your service layer will download the data from fake store. It will filter out whatever properties it needs. It will create the product entity object and populate your database. Are you guys able to get this point? Why do you need two separate classes? Of course, there can be a case that there can be same classes, but 99% of the time there will be need of different classes altogether. I very smartly put this created at, updated at property because generally this property is very much required in most of the tables altogether. But do you guys understand what I'm trying to say here? Now, do you guys understand why do you need DTO separately and why do you need entity separately? Serialization and deserialization is going to be handled by the library direction. For example, retrofit, or for example, OK HTTP and everything. The DTO class is going to be responsible for creation of that object, which will be serialized. Now, just think about it. Your service layer will call the API folder or like API layer. API layer will create the object, or let's say API layer is going to make a call to fake store API. Fake store API will send you back the data in the form of JSON. Now, retrofit will actually use this JSON and convert this JSON into the object of this DTO. And then this object is going to be sent back to the service layer. Now, service layer has the business logic to collect whatever data it needs to have from this DTO. Then it goes to your entity to get the class and create the object of this class. Then your service layer will go to the repository and pass the class, the object of product entity. The repository will take that object and populate the database. So see how the interaction will go on, guys. So your service layer will first of all interact with the API layer. Your API layer will call fake store API. Fake store API, second point. Fake store API will give you a response back. It will give you a response. But this response is going to be in the form of JSON. Now, inside your API layer, you have what? Retrofit or whatever library you are using. This retrofit will take this JSON and interact with your DTO class to create a Java object. Because this JSON will be deserialized, then pass this to this DTO class or constructor, and then Java object you will get. And then you will send this. So this is 3, 4, 5, 6. This DTO object will be sent back to the service layer. Now, service layer will implement the business logic to actually create the object of product entity, because all of the properties we do not need. Now you have a Java object of product entity. How this Java object will be populated to your database? So what will happen is, from your service layer, you're going to call repository layer and pass this object to the repository layer. And repository layer will be responsible for now getting this product entity, converting it to the corresponding serialized object, and send it to the database server and execute the query. Are you guys able to get this point? Drop a big yes or no in the chat. So you can see, why do you need two separate classes altogether? Like if you come from a world of JavaScript, you don't need DTO, you don't need DAO, or you come from a world of Python or Ruby, you don't need this because there you don't have types. If you don't have types, then you have just plain objects, plain maps, plain dictionaries. So you just play with the key value pairs. But in type safe language, you can't do that, right? That's why a lot of people who come from the world of MERN stack and everything, and when they join a Java company, they realize, oh, there's a lot to it. But coming back, is this point making sense? Like it happens, I know. जितने भी बच्चे कॉलेज में MERN stack पढ़ लेते हैं, आई नो कि तुम में से बहुत ही कम है जो कॉलेज स्टूडेंट्स हैं, बट जितने बच्चे कॉलेज में MERN stack पढ़ते हैं, वो जावा का कोड बेस देके उनका थोड़ा तो जिंदगी और जज्बात बदल जाते हैं। भाई ये क्या है, हर चीज का जब इंटरफेस देखना, अब अभी तो ये हमने फोल्डर स्ट्रक्चर में बात करी है, अब हर इन क्लासेस का इंटरफेस एग्जिस्ट करेगा। पहला तो सवाल ये था, हर क्लास का इंटरफेस क्यों बना रहे, बिकॉज दे डोंट नो द कॉन्सेप्ट ऑफ डिपेंडेंसी, इन्वर्जन प्रिंसिपल एंड एवरीथिंग। तो वो लर्निंग कर्व लाने में ही बहुत टाइम लग जाता है। ऊपर से स्प्रिंग में हर चीज एनोटेशन है। How services are directly related to with repository layer? How as in like you want via code, how we will do that, or how as in logically how it happens? Via code, so we will be making function calls. We'll be making function like method calls of an object. Logically, services need data interaction, right? Rahul, just think about it. Your services need data interaction. Think about any application. For example, let's say you are Flipkart and you want to place an order. Now, to place an order, you need to get the product details for which you want to place the order. You need to get the user details and everything. Can I say that, Rahul? Okay. Now, these details are in your database. Can I say that? Now, will your service layer, where your actual order creation logic is there, like get the total price, apply the discount, create this, create that, all of that business logic is present. From that layer only, do you want to do the DB interaction? No. Why do you not want to do that? Because later, let's say if anything changes in the database, now you want to write some more optimized queries, you want to change the database altogether, then your service layer logic will be impacted. Are you able to get this point? If you have written unit tests, then you have to change unit tests for your service layer. Testing will become hard. Tight coupling means maintenance becomes hard. Debugging becomes hard. You will not be able to understand अगर कोई bug आ रहा है तो वो DB level layer पे आ रहा है या business logic layer पे आ रहा है, क्योंकि तुमने तो दोनों same to same लिख दिया. That's why you need a separate layer which is just responsible for DB interaction. We will interact with this layer. We will say get products, and this layer will make a call to select star from products where product belongs to a particular order and everything, and give us the product back. We will take the product from them. Are you able to get this point, Rahul? No, for every DTO, of course, it's not necessary to have an entity. For example, let's say there is a DTO for sending an email. Why do you want to, like, probably you don't want to store that data in your database. So you don't need to have an entity email. You'll just have a email DTO. You'll send the data to Twilio, and that's it. Pawan Patil. Now, guys, there is an interesting thing. Now, inside this repository layer, I mentioned that we are going to actually write all the DB interaction logic here. DB interaction logic means your queries. DB interaction logic means your queries. Now, if you want to write queries, you can write select star from this. You can write MongoDB queries and everything. But we are very much fond of using object-oriented code. In a Java project, writing select star, update table name, all of this kind of a code, too much, can be pretty much, I would say, annoying. Okay. And because of this, what happens is this DB interaction also becomes very tightly coupled also. Because let's say if you are migrating from MySQL to PGSQL, so even the repository logic will not change much. But then if you are moving to something like, let's say, MS SQL Server, which has a very, like, there are a lot of syntactical changes, then things can be pretty cumbersome. So to make our life easy, which if you don't want, you can avoid, inside your repositories, we are going to use something like ORMs. What is ORMs? ORM stands for Object Relational Mapper. Object Relational Mapper. What is an Object Relational Mapper? These are libraries that actually take the world of RDBMS, like the world of select star from products, and map it to our object-oriented world. Like, think about it. If you want to get products, instead of doing select star from products. What if I'm able to do products.getAll? Which one of them is more verbose? Products.getAll or select star from products? Of course, products.getAll, right? So there exists a concept of ORM. So what ORM is? ORM is kind of like a library. It's kind of like a software which will help you to execute DB queries without writing raw SQL. And instead of raw SQL, you can write object-oriented code to execute your queries. For example, so there are a lot of ORMs. Like for example, if you're using Node and everything, then you can use something like Prisma ORM. So if you see Prisma ORM query, okay, for example, so if you have to create a user, then in normal SQL, what will you do? Insert into user, email, comma, name, values, elsa@prisma.io, elsa prisma. You will write a raw SQL query like this. But don't you think this kind of a syntax is very much useful? User.create, and then you just pass an object like this, right? So for Spring Boot, we have a very famous ORM. We'll talk more about this ORM later as well. But because somebody like you might be having this question in your head. So there is an ORM called as Hibernate. What Hibernate will help us to do is, it is going to do one simple thing. It will help us to make sure that we don't have to write a lot of raw SQL queries. We can use a lot of Hibernate generated code. It will automatically generate the code for your corresponding database structure, and we can use that. For example, if you go to documentation and okay, and you don't have to figure out that, okay, I have a product table, I have a user table, how it will automatically create a, I would say, function for that. All of that logic is already written inside ORMs, so you don't have to bother about that. Okay, so we'll talk more about it, but you can see, if you have to, let's say, create a table, what will you do? You'll say create table contact, and you write all of the table property like this. If you're using Hibernate, what you can do is, we are more fond of writing object-oriented code, right? So we can create an entity class like this, and that's it. That's all that you have to do in order to create a table. If let's say you want to make a query, okay, so let me show you a cool query here. Yeah, I'll just Hibernate query. Okay. So there is something called as Hibernate query language also. We will talk about that. But before that, I want to just show you the object-oriented function. Let's see. Okay, well, good. Let's go to fetching. Okay. And you can see, all you have to do is this dot find employee.class 1L. It will automatically execute a kind of like a query for you. See, you don't have to worry a lot. You don't have to worry a lot. You don't have to write all of those joins and everything. If you have prepared your ORM structures well, things will automatically work for you. For example, let's say if you go to batching, right? So not batching, let's say if you want to do transactions, for example. Okay, so you can see there are dedicated code that you can actually use in order to prepare a transactional structure. Otherwise, you always have to, in a raw SQL query fashion, you have to start a transaction, do your code, commit a transaction, all of that you have to do yourself. But all of that hassle goes off with ORMs, right? I can show you Rails ORM as well. So Rails, Ruby on Rails has an ORM called as active record, right? Rails. So that's also pretty cool, pretty useful. So for example, if you want to create a product, right, you can just say product.new, that's it. And then you can assign p.name it something. Okay. If let's say, you can see, you can use something like this, user.create. Okay. If you want to get all the users, you can do user.all. If you want to get the first user, so you do user.first. You can see you don't have to write raw SQL queries or raw DB queries, whatever DB you are using. That's where ORM comes into the picture. So there will be a heavy use case of ORMs that might go on inside the repository layer that we will, of course, integrate once the time comes. I'll talk about what is Spring Data JPA, how internally it works. Don't worry. Let's jump the bridge when we come to it. Which all layers we test? I guess not API layer. We test all the layers. At least in Google, we used to test all the layers. We used to maintain a 95% test coverage in Google. So it cannot happen without testing all the layers. Anjali, it becomes heavy. Spring Boot already is a very heavy framework. So, like, you don't test the third-party API, but the module that is going to interact with the third-party API, like somewhere you're going to make a third-party API call, like you're going to use, let's say, retrofit. So there will be some function, right? Make API call. So that make API call is going to use retrofit to make an HTTP call. So at least that make API call, so we will test, right? Yeah, mock data, of course, using mock data. So we'll mock the fact that, okay, retrofit will be returning us a mock data altogether. Make sense? Anjali, yeah, I was answering your question. Yes, projects do become heavy. But the thing is that ORM comes with their own set of advantages as well. They have capabilities of caching the queries also. The overall developer productivity enhances as well. The code readability and maintainability increases a lot, right? If there is a developer who don't knows MySQL, can get easily onboarded to your project if you are using an ORM, because it's independent of MySQL, right? It's a class object as well. Indexing to chalo, you can do yourself as well. Make sense, guys? So that's exactly how MVC works. And as I said, MVC can be in any project. For example, I can show you a node project, for example. Okay. So you can see here also, if you go, you can see there is a controller layer, DTO layer. There's a separate errors that we are handling. And as I mentioned, once the logic becomes more complex, more folders can be introduced. You can see there is a mailers folder, there is repositories, right? There is routes, there is services, there is tests, there are validators, right? Dedicated types are there, so on and so forth. You can see a lot of layers of your code is going to exist. So this whole structure that we discussed is independent of any language, any framework. Whatever language, whatever framework you are using, you can abide by that. Make sense? And now you know why we use it as well. You now know the use case of why we use it as well. Got it? Any questions from anyone? Like if there is anybody who is already working in some company, they might be able to validate as well. Like generally in companies, you will see all of this actually going on in some way or other, until unless you are fond of writing bad code. Like it's very hard to write bad code in Java, because the moment you start writing bad code, the overall code structure becomes extremely ugly. It's very easy to write bad code in JavaScript. Like you will see a lot of tutorials and everything teaching you back and front end, this, that, and writing all of the business logic, model, and everything inside controller only. Like I've seen projects where people just write controller and then write all of their logic in the controller without any issue. So we will not do that. So when we say the term business layer, I mean all three come under the service, and yes, because that's together is going to handle the whole business logic part. Yeah, Rajat. It happens, right? When you don't work and you just teach, it happens. Any questions, guys? Any questions? I want more questions from you guys. How ORM handles both SQL and NoSQL? Generally, there are provisions, like you can read their code. Otherwise, most of the time you will find different ORMs altogether, right? For example, if you see Node, then in Node there is Sequelize ORM. Sequelize handle most of the RDBMS. Okay, Sequelize doesn't support NoSQL; it only supports RDBMS. Then there is something like Mongoose. Mongoose just supports MongoDB. It's for Node. It just supports MongoDB. But then there exists Prisma. Prisma, on the other hand, can support RDBMS also and NoSQL also. Okay. So you can see for Prisma, ORM, Mongo. You go for here. right? So of course they have written the logic. Like you can read their code if it is open source on this. Like there is something called as a there is a term called as a driver. The driver is responsible for setting up the connection between the database and your code. So depending on the driver, what driver the user wants to use, they can very easily decide, right? That okay, if the user is using a Mongo driver, that means they want to execute MongoDB queries. So all the classes and all the logic of MongoDB interaction comes into place. No problem, Somnath. I hope it was useful. Guys, one last time, any questions from anybody? I'll share these notes on the group. Okay. So that you guys can read more about it. And maybe I'll share a bunch of articles as well for you guys to maybe understand more of the things around MVC, basic MVC, then this enhanced MVC, so on and so forth. Okay. So let me share it on Discord. Oh yeah, I gave you guys a homework. Maybe you can discuss that once we start just the Spring part, but I don't think that should be much of a difficult task. I already did, Puneet. Can you please check? As I mentioned, like both of them are not going in the same fashion, so don't worry. Both are going in kind of like a different way. The whole written on screen is life cycle of if you want to give it any name, you can give it any name, Ayush. I don't think there's a formal name given to it anywhere. Make sense? And again, I'm mentioning guys, like if you see, for example, I showed you Rails, right? If you see Django project repository, project example, okay. If you go to, let's say, GitHub, you can search for any open source project, okay. Let's see. You can see a bunch of models coming up here, right? Views coming up here, right? A bunch of serializers coming up here, URLs. This probably might be the API part, so on and so forth. You can see, right? And in fact, you can go to GitHub. In fact, you can go to GitHub. Okay. And not here. You can search for GitHub Spring Boot open source projects. Okay. Not the official repo, of course. So let's open a bunch of them. Not here. Famous open source Spring Boot project. There was a nice one. I lost its link. Okay. Okay. So here we have a few. So let's open a few of them. Okay. And if you go to source, main, you can see models, services, controllers, a bunch of configs, a bunch of utils. Utils is like extra set of helper functions that you have and so on. Right. Then let's see only GitHub links. contribute on GitHub. Okay, and this is the server. And if you go to this, where is there? If you go to server, probably in the services. Okay, you see client, config, payload, runner. Okay, they have structured it in a different way, but you can see there is a bunch of repository data that is coming up here, right? And bunch of payloads. Payloads is again, sometimes people refer DTUs as payloads, right? So you can see a lot of open source projects you can actually go and see. They will also be using similar code structures. And I guess in Apollo as well, you can find a few. If I open the Apollo client and if let's say go to admin service, source, main, you can see bunch of controllers. They have a AOP folder most probably for defining a bunch of annotations and aspects. You can see a bunch of annotations and aspect to define. Then apart from that, let's see. Let's go back and go back to Apollo. And let's see once again, audit, admin service, assembly, Apollo portal. Let's open Apollo portal. Source, main, this. Okay, here you can see controllers, entity. They have a different folder for enums as well. Repository, service, util. You can see a lot of things are there. Can I say that? So you can find a lot of open source projects as well that follow a similar kind of a structure. And once you start actually maybe working in a company, you will see similar kind of structure being followed there as well. Once we receive the JSON data, the deserialization of JSON to Java object will be done by a library like Jackson. This Java, yes, Rachel, you are absolutely correct. You can use Jackson, you can use Moshi, JSON converter, you can use anything you can use. Okay, cool. Any more questions, guys? Did you guys enjoy today's session? Any more questions from anybody? Okay, cool. In that case, now we have all the prerequisites required to actually start coding a bunch of more things in a new Spring project, right? We'll start a discussion on a few more things. Thanks, Anjali. Thanks for joining. Also, I'll be sharing a few articles, guys. Please go through them. It will actually help you enhance your own knowledge only. It's always good to read a bunch of articles. I'll share that probably by tomorrow. That being said, let's wrap today's session here. We're going to meet soon in the next set of sessions. Till then, take care. Bye-bye. Have a lovely week ahead and keep coding, everyone.